Hello and welcome. Happy Friday. Welcome to episode 7 of Fluke Fridays, where we're going to be talking about today the Fluke-438 and why anyone might care about buying this tool and what kind of benefits it would give somebody if they did think that they needed it. So let's start with a look at what I have set up in the office today as far as demo, so we can talk a little bit about it. What I have here on my office is we have a demo board set up, power quality demo board, and the Fluke-438, which we're going to be looking at a little bit more later. These demo boards are available from Fluke. If you're interested, I'll put the item number below in the description. And these can be purchased if you guys are looking at having a training in at your facility on how to train somebody on power quality or other measurements. It's a nice little briefcase that you can carry with you in demo. Anyways, let's get into it. So what is the Fluke-438 and why did Fluke introduce it since we already have other power loggers? The Fluke-438 was an answer to people needing more diagnostics out of their motors, telling them more about their motors than what our current line offered. Now, if you look at the Fluke-438, you'll see it looks a lot like the other 430 series. It looks like the 434, 435, and the 438, and even the 437. They're all a little bit different and have unique characteristics. Essentially, the 434 is the most stripped down version. The 435 adds all the other power quality features you might want. The 437 is a unique bird. It has the ability to do 400 hertz power logging. So if you have an airplane or shipyards, they run on the 400 hertz world. So those guys care about the 400 hertz, but that's really the only people that care about that 437. And then the 438 does power analyzing in addition to the power quality. So if you look at 434 to 435, you add features for power quality. The 435 to the 437 and the 438, you get the same power quality features, but with the 437, you get 400 hertz. With the 438, you get all of what came with the 435, and you get motor analyzing, but you lose the 400 hertz. Okay, so that's a little bit about the series. Now, if you're familiar with the 435, if you have a 435, and you decide, you know what, after watching this video, a 438 would really be helpful, you actually don't have to go out and buy a brand new 438. There is an upgrade path from the 435 to the 438. Again, these are all Series 2. I don't think I mentioned that before, but this is all 438 Series 2, 435 Series 2, so on and so forth. But we can upgrade a 435 Series 2 to a 438 Series 2. And we have a part number. Again, I'll try to link that below if I can find the website where we describe it. Or at least I'll put the part number so you can reach out to your local distributor and find that. Now, why? I'm not going to go over all the 435 capabilities. If you want that, there's other videos, go find those. But the 438, we're going to talk about specifically these videos and hopefully walk through a little bit. So in the initial setup, you can see this is when you turn on your meter, you're going to see a screen similar to this. You can use Setup Wizard or you can set it up manually. In this case, we're going to need to be in a Delta configuration. I've got everything set up so we should be getting good readings when we get down into it. We're going to hit Menu, and you see page 1 and then page 2. So the 434 comes with all of these features. When you buy the 435, you get these features except for motor analyze. There we go. Click this. Hit enter or OK, either way. Now we're in our setup world and I've got it set up already the way I need it. But all this information, where do you get this information? Great question, glad you asked. You get this information from the nameplate of the motor that you're going to be hooking to. Now you can see it says variable frequency drive. You can use this with a variable frequency drive, but you need to run it at higher on the range of frequency. You can't run it low. I think it calls it out in the specs, but I think it's at least 40 or 50 hertz that you have to be running at. But if you can run it at 60, that's even better. Okay. In this case, we don't have it on a VFD. I'm going to hit start, and now we get into this mode. Let me turn it if I can see it, get your colors better. Now you can see the green and the yellow, orange, and red. So Fluke's trying to make more and more tools that are intuitive, that you don't have to be the expert to understand what you're looking at. So right here we see green, yellow, orange, red. Obviously if it's in the red, that's bad. If it's in the green, that's good. Now, what are we getting? When we first turn it on, you can see we are in the mechanical health screen, and these black bars kind of show you where they are on that scale. We can then hit the down arrow and go to the electrical health screen. Again, arrows, and you can see I have a little unbalance, which I might be able to fix that. Let's see if I can. There we go. I'm fixing that, messing with my demo board over here to the right. Okay, now let's go up again. In the electrical health screen, let me go over that. You can get kilowatt, so electricity you're using, power factor, unbalance percentage, and then harmonics. Okay, and in the mechanical health screen, you get kilowatts mechanical, you get torque, and you get RPMs in efficiency. Now, why is this so cool? Well, the neat thing is you can now get a lot of mechanical readings and components that you used to have to go send your motor out to a dyno station and put it on a dyno and do the testing to see its performance. Now you can do that all via electrically and doing calculations that the machine's doing for you. Now, why is that beneficial? Well, one, it costs a lot of money to tear down a motor. You're without your motor to go send it off for performance evaluation. So where does it actually come into play that you would want to look at performance? There's a couple things that I've heard of. One is like in wastewater or any kind of pumping system. If you get a blockage or the viscosity of the material changes, you can put more stress on that motor and create more mechanical stress and then wear your motor out faster. So maybe you need a more beefy motor, maybe you need to look at your system and see if you can correct something. You can also get the same thing if on conveyor systems. Let's say you're in some kind of shipping facility and you drop something way too heavy and you bend one of the shafts and you think you bent it, but you're not really sure. Are you stressing that motor? You can tell. You can hook it up and see if you're stressing that motor. Another example from a customer that I have is they do submerged pumps and they can't get down to do any kind of diagnostic on the motor because it's 10, 15 feet underwater. In this case, they can actually use this, measure it, the leads are going down into the water, but they can measure it up on dry land and see how their motors are performing without being down there. And it really gives them that capability. Obviously, that's not something you could even send to a dyno shop. They don't have the ability to do something like that. So those are some reasons why somebody would care about this and where they might use it in the field. And let's talk a little bit more about it. So I'm going to mess with, like, if you were to bend a pipe on or bend a shaft on a conveyor system, have high torque, something like that, or have higher viscosity or a blockage in a pump, where would you maybe see it? Well, let's look at if I mess with some of these. If I increase the amount of current draw on each phase that this is pulling, you can see all of a sudden now we're stressing that motor more. Or it's perceived that way, but that's how it would look in the field if you really were stressing your motor more. You get over here to the orange or the red, you are either A, you have an undersized motor, or B, something changed in your system and it needs to be fixed or you're going to start burning through motors faster than you should. So that's kind of a little bit about that. And we looked at both the electrical and the mechanical health screen. Let's also look at the NEMA derating. So this is kind of a cool little chart. If a motor is running properly and it's in the green and it's running the way it should, and you're not oversized or undersized, what you should see is you should see this crosshairs running along this green-yellow divide. okay, as it runs. And you can leave it in here, and as I mess with some of these parameters, you'll see it'll change. Now I'm kind of overstressing this motor, and it's getting up into the yellow. If your motor is running in this continuously in the yellow, then it's not going to be happy with you. It's going to start failing more quickly. Now, conversely, if you're down here all the time, way low in the green, sorry, let me get these things out of the way. You can see it kind of is plotting with dots. But if you're way down here in the green, you probably have an oversized motor for your application, and you're burning way too much electricity to turn this huge motor when a much smaller motor will do the job. So this is a little bit about the 438. It's not everything you need to know about it, but it's enough to get you started and understand why somebody might buy this tool or not buy it. I hope this helps, and give me a thumbs up if you liked it, and pass it on to somebody that you think it might be useful to. Thanks, and have a great weekend.